Hi everyone. We're going to look at how to solve a system of equations here, linear equations, using the elimination process. What that does is it eliminates one of our variables so that we can solve for the other variable. Because right now we've got x's and y's and we've got two equations. So it can be done, and elimination can be a pretty quick way to solve for one of the variables. What we have to always look for when we're trying to do elimination is look for opposites. If we have opposites, they're going to be eliminated very easily, and that's key to make things go quickly with the elimination process. So what we want to do here is look to see, first off, is everything lined up? Do we have the x's together above each other? Do we have the y's above each other? And do we have the equal sign above each other? And then do we have the constants lined up as well? And we kind of do. They're a little bit off, but they're all above each other in order. If anything was mixed around, you'd have to reorder it first to make it easier to work with. We're all lined up, so we're good to go. Now I want to look for opposites. Do we see opposite symbols, opposite numbers in front of our x's or in front of our y's? If we do, we can just add the equations and we can eliminate things immediately. And if you look here at the x's, we've got -3 and a +3. Those are opposites. The y's do not have any opposites. The +3 and a +1 are not opposite numbers. We could make them into opposites, but we don't need to because we already have the x's as opposites. So now that we have opposites, we're going to just add these two equations together. So we're going to do -3x plus 3x, which would be 0x, which is nothing. So we could just kind of cross those off. They're eliminated if we add those. 3y plus 1y is 4y. Bring down the equal sign. And then -18 plus -22 would be a -40. And that would be our first step. Now we've got just one step left to solve this. Simply divide by 4, and we've got our y equaling -10. And we're not quite done. We can't just find the y. We've got to find the coordinates where these two lines intersect. And the y coordinate is only half of what we're looking for. So now we've got to find the x coordinate. So looking at these two equations, either one is totally fine to work with. Usually I use the one that looks a little bit easier. I might use the second one. It's got fewer negatives in it, so it might be a little bit easier to work with. So let's try that. And we're going to take our answer and plug it in for our y in order to find x, the other half of the coordinate. So 3x plus 1 times our y equals -22. We're just going to solve this little equation for x. So 3x minus 10 equals -22. And look at that, we got a nice little two-step. We're not going to touch the variable. We're going to move the -10 by adding 10 to both sides. We get -12 equaling 3x. Divide by 3 on both sides, and we get our x coordinate -4. And now we've got our answer. As a coordinate point, it's -4, -10. Always the x, followed by the y as a coordinate point. The beauty of math is that we can always check our answer. We could take -4 and -10, and we can make sure that this works. So we can take the coordinates and just simply plug them into the equations to show that it's true. So let's check equation 1. -3 times our x plus 3 times our y should be -18. We shouldn't say it's equal yet. We want to show that it's equal. So this is going to be +12 minus 30. And then that would be -18 on this side, and that equals -18 on this side, so we're good. And it works in the first equation. Then we check the other equations, got to work in both. 3 times the x, -4, plus 1 times the y, should equal -22. So this is -12, this is -10. Adding those together, we get -22 over here, and that equals -22 over there, so we are correct. We've checked our work. This is definitely the answer, and we just proved that it is. Now, a little bit trickier here if we don't automatically have opposites. So we've got this example down here. What we want to do first is get things lined up. I've got an x, a y, an equals, and a number for this one, but not for the top one. So I want to rearrange the top one so it's easier to work with and all lined up like the bottom one is. So -5x equaling -50 plus 1y. We're almost like this one, except the y's are in the wrong spot. So I'm going to move those over by just using the opposite operation. -1y. And I get -5x minus 1y equaling -50. That's the same as the first equation. It's equivalent. It's just rewritten so it's all lined up like we like. X's, y's equals number, constant. Now we can bring down the second equation underneath it and look for opposites. 3x minus 5y equaling -26. So if you look here at these two equations, we don't have any opposites. The x's are not opposite, and the y's are not opposite. So we have a choice here. We can make the x's opposites, or we can make the y's opposites, but we got to have one of them to be eliminated here. So looking at the y's, I see a -1. Now any 1 or -1 is very easy to manipulate to make it into any number you'd like using a scale factor. So I'm going to do that. I'm going to take the first equation, I'm going to scale it by something to make it an opposite with the y's down below. If I have a -5y, I need a positive 5y up top. To do that, I've got to multiply the whole top equation by -5, every single part of it. So that becomes positive 25x, because the -5 times a -5. And then -5 times -1y is plus 5y, equaling, don't forget the right side, that's often the mistake here, -50 times -5 would be positive 250. Then I'm going to just copy down the other equation, 3x minus 5y, equaling -26. And now I have opposites here with the y's. These are opposites, which is good for elimination. That's what we want to do. We want to eliminate things by adding here and getting them to go away. So when we do that, the y's are eliminated, and we're given 28x equaling 224. Then what we need to do is just simply solve this one-step equation, divide by 28 on both sides. So we do x equals 224 divided by 28, which is 8. We're not done yet. That's just the x. We've got to find the y. Pick your favorite equation from the first two that we were given, or you could technically use this one over here that is equivalent. Doesn't really matter. I'm going to use, just for fun, the first one. Why not? So -5 times our x equaling -50 plus 1y. I need to solve this for y. So this is -40 equals -50 plus 1y. One more step here to solve. Just add 50 to both sides. And positive 10 equals our 1y, since these are gone. So our answer is the x-coordinate with the y-coordinate as a coordinate point. So 8, 10, the x and the y, there's our answer.